Before we leave the linked list, I think it's worthwhile taking some time to make sure you really understand what's going on with the linked list. In particular, the traverse functions caused us some trouble. So we did traverse because we're trying to address the problem of getting to the data in our linked list when it's all private. We don't want to make it public because the whole reason in creating the linked list is to protect that data from unauthorized usage. So the traverse function basically gives us a way to get inside of the linked list program and make a program or make a function that we define in a separate program, which would be external, make it run as if it were inside of that. Okay. So that's kind of the idea. But then using it gets a little bit tricky. So I started off here in giving you um, what the traverse function looks like. Okay. This is from the linked list.cpp code. Okay. So it does the following here. And again, what it takes is a process, a pointer to a process, which is going to be a function name. Okay. So it's just going to iterate. Again, it's inside of the linked list class. So it can get to the head and it can get to the data and all that, which you can't do outside. Okay. So the functions we write in our application programs can't include these. Okay. So it just does a while current not equal to null pointer process current data that's going to send current data to the function that we create, and then it's going to increment. That's it. Okay. So the problem we're going to work on today that was one that was assigned for homework, and it's merging two sorted lists. So I think this is an interesting problem, and it tripped me up too when I was first doing it. In fact, I may have answered some of your questions incorrectly because I hadn't fully thought through it. What we would normally do with merging two sorted lists is that we would use pointers and go through and compare and do all that stuff. Well, we can't do that with traverse, okay? If we were to add this function to the linked list, then we would be able to do it, okay? But we can't. We have to think about what traverse can do, okay? So traverse basically is going to just go through and allow us to collect values. That's it, okay? So that's really all that we can do. Okay. So if we're going to create this, we're going to call our function to pass collect values. Okay. It has to be a void function. Call it collect values. It has to take an int. Okay. That's just the definition when we pass it to traverse. Okay. Which means that any storage that we need, we're going to have to make a global variable. Okay. So we're going to pass values into traverse. The the function, this collect values, will sit inside of there. Okay. So in some ways we can think of this line, okay, will actually be whatever the collect values code does. We'll go right here. And value becomes current data. Okay. Or current data becomes value. Okay. That's where we're headed. Okay. So what this is going to allow us to do, what this function needs to do, it's inside of traverse. It just needs to save out the data that's in the two lists one at a time. Okay. But we can't store them inside of a linked list, so we have to have global variables. Okay. So I'm going to go ahead and just create a an array. Okay. And the array is going to be used to track the data that we have here. Okay. So I'm going to create an int array called values, and we'll just give it 200 to hold both lists. Okay. Again, if this were a real program, you'd want to do something different. You want to do something dynamic. But for this case, 200 is way more than we're going to need. Okay. And as always the case, when we're dealing with arrays, we're going to have a count so we know how many are actually in it. Okay. There probably won't be 200, so we'll have to know what that is. Okay. Those are our global variables. So I've gone ahead and just to give a update here of what I've done so far with the program, including my IO stream, and I'm including the link list.h. We'll have to include the link list.cpp on the line with the G++, unless you want to rewrite a make file. Okay. And this is just a comment on that. Here's our global variables. Okay. And now we have this function. Okay. And what do we want it to do? Okay. So if we're in here, so let's think this way. Okay. If I'm inside of here and I have access to the first data element, then the second, then the third, what do I need to do that? Okay. So I need to add it to my values, right? My global variable. So I'm going to say values sub value count. Okay, so again, value count will start at 0. Okay, and I needed to make that clear. It usually does anyway. Okay, so the first one will go at position 0 is equal to, and it would be current data up here. Okay, but we're passing that in from down here as value. So our function needs to say value. Well, I guess I could leave it up here and then we'll just translate it when we go down. Okay. We're going to do that. Okay. And then we just want to do a value count plus plus. Okay. So that all needs to happen. I'll just put this further and dent it over. This is a comment. So this is what our function is going to do, right? And that's all it can do. Okay. Which means down here, I'm just going to have my values at position value count equals value. Value becomes the current data. Okay. And then value count plus plus. Okay. And that's all it can do. Okay. This doesn't get us done, right? We're not at the end yet. And I'll just make that explicit. Okay. All this does when we send it a list, it's going to transfer the list to the array. Okay. So this is of limited usefulness. This is an academic exercise. We're trying to learn how this works, right? In real life, you wouldn't do this. If you have it in a linked list, there's no point in trying to put it even temporarily into an array. Defeats the purpose of a linked list, okay? But it's useful in helping us to understand how to program with the linked list. Okay, so that's where we're headed on this one. Okay. So now that we have our persistent storage, and now that we have our function, we have to figure out what we're going to do with it. Okay. So again, there's the temptation to do too much. So the too much that we often do here is that we want to loop in collect values. Okay. Don't need to. In fact, it's wrong if we do. We're going to embed this function in the traverse function, which here's our loop. Okay. So the loop's already there. So we're writing a function to insert inside of here. And that's it. That's all it has to do. Okay. So that should be all we need. But what does that give us? So we're going to have a list A and a list B. Okay. And we can further test this. Let's say we have um, a list A equal to say 1, 2, 3, and then list B is equal to 4, 5, 6. Okay. And it turns out as we write this program, it doesn't matter at all whether they're sorted or not. Okay. Doesn't bother. It's whether the initial lists are sorted or not makes no difference. We're going to sort them anyway. Okay. So what this means is after we run this the first time, okay, so we're going to call our function collect values on uh, the list A. Okay. I'm going to send that to traverse. Actually, we're going to send the list A dot traverse the collect values. After we do it for A, then our array, okay, our values array would be equal to that 1, 2, 3, and then the next time we'd run it on B, we get 4, 5, 6. Okay, and in this case, it is sorted, but we can't guarantee that. I mean, we can't just assume that we're done because we could have a 10 here. Okay, and that would be a 10, and each one sorted, but the two together would not be sorted. Okay, so we have to sort this array. We sort this array independent of anything else. I'm not sure if you've covered sorting arrays or not, but you could look up pretty easily different sorts. I'll use the insertion sort. You can use a bubble sort, but they're kind of super inefficient. Insertion is probably the best choice here, okay? But it doesn't really matter. But it's gonna be up to us to sort it, independent of the linked list. Okay. So again, this video may be long. I hope not, but I want to make sure we understand this. Using traverse and using our collect values function, we're going to go through each linked list one at a time, pluck each value of the linked list into this global array called values. And we'll know how many are there because we're keeping track of that. Okay. And that's it. So let's go ahead and write another function. It's going to be our outward facing function that's going to call the collect values. It's going to kind of do all our work for us otherwise. Okay. So I'm going to call this function merge lists. Okay. And it's going to return a linked list. Call it merge list. It's going to take a linked list. I'm going to pass it by reference because it's a linked list. List A and linked list B. Okay. That's what we're going to pass in. Okay. So our first step here, we're just gonna make sure this hasn't been called before. So I'm going to set the value count equal to 0. We've done that once when we declared it, but it doesn't hurt to do it again. Okay. Sorry, the spring flowers are starting to bloom, getting me. Okay, so now that we've just made sure that's the case, we can now say list A. We haven't created list A yet, but if we had it, we're going to call traverse its version of traverse. Okay, the traverse is defined in the linked list, so we create a linked list called uh, list A. It can get to traverse. Okay, we're going to send it the collect values. Okay, not that, not with parentheses. Okay, it's not a function at this point, it's a name. We're sending the name of the function. Okay, so at this point, whatever's in A, 1, 2, 3 in our example, or 1, 2, 10 as we did it, will now be in our array. Okay, do the same thing, list B dot traverse, collect values. Okay, now all of the items from A and B are in our values array. Okay, so at this point, traverse is going to walk through both lists, collect all the values. It's going to do it repeatedly. In our case, it's going to run through 6 times. The function will run 6 times. Okay. Getting us all that we need. Okay. So at this point in our code, what do we have? Okay. We have values contains all the data. Okay. Um, we could test this out if you want. If to make the video shorter, I won't. But if I was doing it for real the first time, I would. I would go through and just do a for loop from I equals 0 up to, but not including our value count. Print out each one. Make sure you're getting everything in your variable or in your array. Okay. But we're not going to do that for the sake of time. So again, now I'm going to do an insert or an insertion sort the array, the value array. Okay. So this, start with a for loop for int equals 1. Note I mean 1 here. Okay. Less than value count plus plus. Again, an explanation of the insertion sort is outside the scope of this video. We will talk about sorting a little bit later. So I'm going to set a key equal to values at position I. Okay, and then I'm going to set an int j equal to 1 minus I. Sorry, I minus 1. I minus 1. Okay. So we're going to compare values, adjacent values as we go. Okay. So now that I've set J, I can do my second loop. We're going to do a for J. No, sorry, it's not a for. This one's a while. While J is greater than or equal to 0, and as long as the values key, no, sorry, values at position J has to be greater than key. Okay. As long as that's true, which means we're still in order. Okay. We're going to let values I plus J equal values J. Okay. Then we do a J minus minus. Okay. Gets out of our while loop. And then I have my values at position J plus 1 equal to the key. Okay. So what this does in a nutshell, it's basically going to go through and um, put pick up the first value that's not in order, that's too big, and move it to where it needs to go, basically. Okay. So once we have that sorted, okay, we can again do a print, and that print would tell us, okay, so I could say here, could test to see that values is sorted. Okay. We're not going to, but we should. Okay. But if you look at the function and look at the problem, we need to create a new list. Okay. It returns a typed linked list. So we have to create a new list with this data, right? So notice that we haven't touched either list. List A and list B are still what they were. Okay. Um, the the traverse just went through them, didn't didn't kill anything. Okay. So I'm going to create a new linked list object called result. I'm then going to go through for int I equals 0. I is less than value count plus plus. Okay, I'm going to do a result dot insert end values sub I. Okay, we have to use the insert end or go through the list backwards, right? Because insert beginning would reverse things by putting everything at the end. Okay, so that's going to add everything to the list. We should be done. We can now return that result, which is the linked list. Okay, that's about what we need to do there. So we now need to write our main function. Okay, so I'm just going to do a linked list list A and a linked list B. I'm going to do list A dot insert end. I'm going to copy this 3 times, copy 6 times. Okay. Tab key will line those back up. So A gets, in this case, let's just do something different. We do 1, we do 4, we do 7. Okay, then we do a 2, not there, 2, that's not a 2, that's a 2, 3, 6. Okay, So that's just adding things to our linked list. No problem there. Then we're going to say linked list merged. The name we're going to give it is equal to merge lists, list A and list B. Okay. That should create the new list. Our function again returns a linked list, so that should be good. Then we can see out merge list. So what I would do, I would say um, list one and merged. I don't know how that works. Let's just do it this way. Let's do list one. I forgot if we could do that inside of a print line or not. And then merged print. No, sorry, that would be list A. List A dot print list. Okay. Then I'm gonna copy that or kill it and yank it. We'll do list two is list B, and then sorted merged list would be merged dot print list. Okay. And that should do it. Okay. So we're gonna call this on A, the inserts. We're gonna have 147 in there. Okay. When we call this merge list function, that's what we call it. The merge list function, okay, for A and B. So A has 147, B has, that's not going to work. When you cut and paste, you got to remember to go back and change things. That's a list B, okay? So we come up to here, okay, to our merge list here. When we call this function on traverse, send it collect value, okay? It's going to call collect values on one the first time, add one. Then it's going to call collect values on four, add four, and then seven. This will do the two, the three, and the six, whatever our values were. Okay. We're then going to go through and sort, create a new list, return. Okay. Our lists have constructors. So when they go out of scope, or sorry, destructors, we don't have to worry about it. Okay. So I did a version of this before to make sure it worked, and it should, but let's go ahead and just see if I made a typo. I probably did. I'm not going to spend video time correcting it unless it's super simple. Okay. So the program I want here is the merge demo, but remember I have to include the linked list.cpp, and then my dash O would be merge demo.exe. Okay. And it doesn't like something. Yeah, who knows what I did? Because linked list does have traverse. Could have spelled it wrong, maybe. Yeah, I'm sure it's some typo issues for sure. Okay, let's see. Where's my real example of this? Just to show you. Oh, actually, I think I put it. Just a second. I want to show you it running and without having to worry about correcting my errors. Is it here? Yeah, merge list. Okay. So merge list.exe. Okay. So the list A, 147. The list B is 236. And there we have the correct version of that. Okay. So hard to say what typo I made on the other one. And we can just look at this code if you want, just in case you're trying to run it. It's not available yet, but I'm going to make it available as soon as the video is over. Okay. But again, I probably included something wrong, but you see it's doing the same basic thing. I did a bubble sort in this one, then I decided that was a bad idea, so I replaced it with the merge sort. But that's not where my error is coming from, so that's not it. Okay. So again, bubble sort's okay, but people will kind of point and laugh at you, so better off using a an insertion sort. But this one's fine too. Okay. So that's it. The main idea is then, and I really think that the visual key, what finally helped me to figure this out, is to write the traverse function out a little bit, okay, and then assume or then put my code for my function temporarily inside of that, just so I can see what's happening. Okay, so I think that's the important step to take. Okay. So if you have questions about this, let me know. What we'll do soon. I'm not sure. I haven't decided if we're going to do it before we get to modeling stacks with linked list or not. But I want to go ahead and add the iterators. It's a little more code to get the iterator set up. That's why we didn't do it before, but it makes it a lot more straightforward to use than Traverse is. It's easier for us to see. Okay. With iterators, we can appear to go through the list one by one. Okay. So I will probably do that before we get to the linked list um, modeling uh, arrays with linked list. Sorry, or modeling stacks with linked list on Friday, I think. But we'll see. It should work either way. Okay. If you have questions, let me know.